Hi everyone, thanks for joining me today. My name is Christopher, and in today's video, I'm going to be walking through the binary search algorithm. Specifically, I'm going to be covering what it is, giving some examples to help us understand, and also solve a leak code problem to help us visualize this algorithm. So without further ado, let's get right into it. So first of all, what is binary search? Binary search, it is a searching algorithm that you use to find something. And this isn't something that you only use in programming or coding. You can use this in everyday life. So over here, I have an example that can help us understand a little bit better. So say we have a list of numbers that are sorted, and we're looking for the number 23, right? So what we do is first we set our positions, right? And what that means, we look for the lowest position, right? And we count from 0, right, and on. So the lowest position here is 0, and then the highest position is 9. We have 10 elements here. So now we add these two numbers and we divide by 2. That's going to give us our midpoint position, which is the fourth position, right? So now we look at the number that is in this midpoint position. Now, if that number that's at that position is greater than or equal to the value that you're looking to, if it's equal to, then you can stop. But if it's greater than, then you want to look in the lower half portion, right? If it's less than, if the number that you're looking for is less than, then you want to look in the second half portion of your list. So in this case, the number 16 is less than 23. So we're going to look in the second half of our list. So now we start off, we move up 1, right? Now the left is that beginning portion, which is 5. Our high remains the same. We add those two, divide by 2. Now we get the midpoint being 7, and the number is 56. Now we ask ourselves, is 56 greater or less than 23? In this case, it's greater than. So now we're going to look in the left half of our list. And we keep repeating this until eventually we find our number 23. So we use this specific algorithm because it saves us time from having to look one by one for any specific item or whatever you're looking for. Another good example is a dictionary, right? If you're looking for a specific word, you're not, let's say you're looking for the word dog, you're not just going to go in the A column, look at all the words, and then the B column and the C. It's going to take you a while, right? What you can do is, you're looking for the word dog, you know that dog is in the first half of the alphabet, the letter D is in the first half of the alphabet, and you know that it's in the beginning, the first few letters of the alphabet. So you're going to look at the beginning of that dictionary. So this is an example of how that saves you time. Instead of going one by one, you can split your search in half every single time until eventually you get to what you're looking for. So the time complexity of this approach is O log of n, and the space complexity is O of 1. So now we're going to be going through a leak code problem. We have the first bad version leak code problem here. And basically, we are a product manager and we realized that the latest version of our product failed the quality check. As a result, any version that comes after that version will also fail and be a bad version. So what we want to do is we look at a list of versions and we want to find out which is the first bad version. We already have a function that helps us and tells us if a specific version is bad, right? So now we just need to implement a function that'll help us find the first bad version. So here's an example. So we have an input, we have 5 versions, right? And the bad version is 4, right? Output is going to be 4. That's the first bad version. Now, in order to explain this, we call is bad version, right? So we know that from 4 and on, if we have 5 versions from 4 and on, all the versions are going to be bad. So if we were to call is bad version and we say 3 to check that version, it's going to come out false because that's not a bad version. If we look up 5, if we want to look at 5, we know that that's after 4 and 4 is the first bad version. So it's going to return true. And then if we call is bad version 4, also true. So now we know that the first bad version is 4. So my implementation is right here. I did everything in Python. So similar to that example that we saw earlier, my approach is I want to take a list, right? Where it's an n numbered list, and I want to start at the beginning portion, have a low or left side, and have a right side or high, which is n amount of versions, right? And then I want to look for the midpoint and then start to evaluate from there, and then see, is that midpoint a bad version? I'll call the is bad version. Check, is that a bad version? If it is, then that means I'm gonna look either at that position or in the lower half, right? If it's not a bad version, then I'm gonna look in the right side, and then I'm gonna change the left and right values, and I'm gonna keep repeating that until eventually I reach the first bad version. So that's what I did over here. So we have our left and right set to 1 and n. And then I created this loop here that's going to repeat as long as left is less than right. So now we set our midpoint, which is going to be the rightmost point minus the leftmost point. Then we divide by 2, and then we add that to left. And that's going to give us our midpoint. Now we check that value. We have a condition statement here that checks this midpoint here. Is it a bad version? If it is a bad version, then that means that the first bad version is either that number or before. So we're gonna look. We would look to the left. So then we set right equal to mid, right? Because basically, if it's on the left hand side, then we want to bring the right closer to the left until we find our first bad version, right? If it's not, right? If that midpoint value, let's say it's 3, right? Let's say it's not a bad version, then that means that the first bad version is gonna be after the midpoint. And in that case, we want to bring the left side closer to the right. So we're going to make the left side equal to the midpoint and add 1. So that way we start at the very next element, right? And we'll keep repeating this until eventually left will be equal to right and will give us the first bad version. So I just return left. You can do also return right because they'll be equal to each other in any case by the time it keeps repeating. So I just return left. So if we run this code, here we'll run. You'll see the input is 5, input 4. Right, the answer is 4 over here. So runtime 27 milliseconds. So this is the binary search algorithm, and what you saw was a simple way to implement that. And I hope that it made sense and you were able to understand this specific algorithm that will save you plenty of time when you're working with the sorted lists. So I hope you enjoyed this video, and I'll see you in the next one.